Hey, what's up, everyone? We're gonna solve the next problem in sliding window pattern, which is to find minimum size subarray sum. And it's a medium problem in LeetCode. First, we'll go over through the description of the problem. We'll try to understand what it does, and then we'll go over through the solution, right? So for this problem, basically you're given an array and you're supposed to find the minimum length of subarray whose sum is greater than or equal to target. So for example, you have 2, 3, 1, 2, 4, and 3 here. And you're supposed to find subarrays within this array which has the minimum length but also whose sum of the subarray is greater than or equal to target. So in this case, the output is 2. So 4 and 3, which would add up to 7, has like equal sum, which is equal to the target. But also this first two subarray is lesser than the target, so that's why we didn't take it. Even the first 3 is lesser than the target, so we didn't take it. Subarrays there are subarrays that are higher than the target. We didn't take it as well because we have a tiny subarray which is actually equal to the target. So in this case, we're taking that. So we're supposed to find the minimum length subarray that is either equal to or greater than the target, right? So I tried to solve this on my own, but I couldn't. So I ended up looking up a solution from a really cool YouTuber called Nick White. So that's how we're going to solve this problem. Basically, we would do an iteration for this array, and then we would have another pointer called start, which would hold the starting point of the subarray, but then the iteration would have the ending point. And then as we iterate through the subarray, we would add it to a local sum and we would check if it's greater than or equal to the target. If it is, we would do another iteration where we start subtracting the start from the local sum, and then we would update the I think it's better to actually show you as I code it out in Java, right? So I'm going to set the initial, so we need to return the result as an integer. So I'm going to set it initially, I'm going to set it to the max value. So integer dot max value, and then we need another variables just to hold the local sum, so that when we do the iteration we can hold the local sum. I'm going to set it to 0, and then do we need anything else? Yeah, we would need the start pointer as well, so we will need that, and then we need an iteration, nums dot length I plus plus, right? So this is the initial iteration. What I'm going to do is that I'm going to keep adding values to local sum. So in this case, it's going to be I. So we would initially have 2, and then 3. We would have 2, and then we would add 3 to 2, which would give us 5. And then so this is what happens right now. But after we add every single element in the array, we're going to do another check to see if the local sum is actually greater than or equal to, oh wait a minute, so um, whose sum is greater than or equal, yeah, right, so whose local sum, if it's greater than or equal to the target. So in this case, we have 2, 3, 5, 6, and then 7, 8. So 2, 3, 1, 2, and then when we go over to 2, we have a sum of 8, which is obviously higher than 7. So in this case, we would go into the while loop, and what we would do is that we would basically reset the value for result. So result would be math.min of result. We would take the minimum value, and then we would store the length of the subarray. So in this case, when we do the initial iteration, we go over to 2, 3, 1, 2, 5, 6, 7, 8, and then the length of the array is 4. So we would compare 4 with the result, which during the first iteration would be a max value. So we would find the minimum math.min of both these values. So in this case, integer.max, comma, which is 4. The way that we would calculate 4 is by, what was it? There was a way to calculate 4. Um, what was it? So we would basically need to subtract it. So I minus 1 plus start, which would give you the length of the subarray. So I meaning we're at the end of the subarray, and then we would subtract 1 because wait a minute. So yeah, so we would subtract 1 from it because we would need the exact length. We don't need the index, and then we would add start. Wait, no, we would add 1, and then we would sorry, I'm getting confused a bit. So we would add 1 so that we would get the exact length of the subarray, and then we would subtract start so that we don't include the few initial. We don't include the elements that are before start, right? So that's kind of the idea here, to get the size of the subarray. Then once we get the size of the subarray, what we need to do is we need to subtract the start location element from the local sum. So we would do nums of start, and then we can go ahead and increment start because we don't really need that anymore. So when we increment it, we are basically reducing the size of the subarray, and then we would try to see if the reduced subarray is greater than or equal to target. So in this case, if it is actually greater than or equal to target, we would again replace the result with the smaller subarray length. That's how we would keep updating the result. And then the while loop would break if at all the local sum becomes lesser than target. In this case, we would need to include the next subsequent element in the array. So once all that's done, we just need to return the result. There was an additional condition in the problem where if we don't find a subarray like that, we would return 0 instead. So before we return the result, we would do a comparison to see if it's not equal to the initial value, which we set it to max value. If it's not equal to max value, then we can go ahead and return the result, or else we were not able to find any minimum subarray, so we're returning 0. So I'm gonna try and run this. Let's see if this passes the test cases. Oh wait. Oh, there's a typo right there. My bad. I'm gonna run it again. Right, so it ran. I'm gonna submit it. All right, so it got accepted. So that's kind of the problem here. We're using a pointer to start, and then the iteration pointer to hold the end, and then we have another loop inside to check if it's greater. If it's greater, we keep reducing the first pointer one by one, and if the length of the subarray during each one of those iteration is lower, we're replacing result. Yeah, so that's pretty much it for this problem. I will see you again tomorrow for the next medium problem, which is weird. With fruit into basket, I've never done that before, so we'll see that tomorrow.